Trig Ratios, Part 4, Sine, by Jeff Simpson, masterylearningsystems.com. There's a lot to know about sines. This video just focuses on these 5 meanings. A sine is a line on a circle. A sine is part of an isosceles triangle. A sine is part of a right triangle. A sine is part of an equilateral triangle. And a sine is a ratio comparing the lengths of two sides of a right triangle. Let's get started. If you connect 2 points that are on the circle, you have a chord. Chord is from an ancient Greek word meaning the string of a lyre. A lyre was a harp-like instrument, so that string is called a chord. Another word for chord is sine, which is abbreviated SIN, but still pronounced sine. Means the same thing. Sine comes from a Latin word which was a sloppy translation of the original Sanskrit word, jiva, that meant bowstring. And you can see how that is like a bowstring. A sine is a line on a circle. A sine, or chord, touches the circle at 2 points. Sines can be long or short. Sines or chords can go any direction. Here are 2 radii connected by a sine or chord. So there's one radius, there's another radius. Those are radii, connected by a sine, also known as a chord. An isosceles triangle has 2 legs of equal length. The 2 radii are the same length. The sine connects the radii to make an isosceles triangle. A sine is part of an isosceles triangle when the triangle is made from parts of a circle. If you split an isosceles triangle down the middle, this is called dropping an altitude, you get 2 right triangles. Here we see an isosceles triangle formed by 2 radii and a chord being split down the middle by an altitude to create 2 right triangles. That means they contain 90-degree angles, of course. When we erase one of the right triangles, we no longer see the whole chord. We only see half of it. After this, we will use the word sine to mean half of a chord. The ancient Sanskrit word jiva originally meant chord and later came to mean a half chord. Here we see 3 chords. And here we see 3 sines. They are half of a chord. A sine is part of a right triangle when the triangle is made from parts of a circle, such as these 2 radii, a chord, an altitude, right angle, get rid of the radius, get rid of the chord, you've got a sine, there it is. The 3 sides are named sine, altitude, radius. All the sides of an equilateral triangle are, of course, the same length. and all the angles are the same, namely 60 degrees. If one of the sides is 1 unit long, then all the sides are 1 unit long. If you split an equilateral triangle down the middle by dropping an altitude, you get, of course, 2 right triangles. The base of each right triangle is half a unit wide. We use the decimal form of half, 0.5 or 5/10, which is equivalent to a half. The altitude divides the 60-degree angle into 2 30-degree angles. The equilateral triangle has become 2 right triangles. Each one is a 30, 60, 90 right triangle. If we remove one of the triangles, we see a 30, 60, 90 degree right triangle whose hypotenuse is 1 unit long and the short leg is 0.5 units long, half of a unit, 5/10. Here's another view of the same triangle, rotated. Here we see an equilateral triangle formed by 2 radii, each 1 unit long, and a chord 1 unit long. 60 degrees is the central angle. And now it's split down the middle by an altitude to create 2 30, 60, 90 right triangles. When we erase one of the right triangles, we no longer see the 1 unit long chord, we only see the 5/10 unit long sine. It's half of a unit. A sine is part of an equilateral triangle when the triangle is made from parts of a circle. The ratio of the sine to the radius, here we can see it's 0.5 to 1, or 1/2 to 1. The ratio of the sine to radius is 5/10 to 1. The central angle is 30 degrees. The sine to radius ratio of a right triangle with a central angle of 30 degrees is 0.5 to 1. A sine is a ratio comparing the lengths of 2 sides of a right triangle, comparing the sine to the radius. The sine to radius ratio is usually abbreviated as the sine ratio. And actually the sine ratio is abbreviated as just the sine. Why? Why is the sine to radius ratio abbreviated as just the sine? Here's why. Ancient mathematicians and astronomers came up with a very clever idea. It's the unit circle. You see in the circle, the radius is 1 unit long. Of course, every radius is going to be 1 unit long. Every radius in a unit circle is always 1 unit long. Could be 1 foot, 1 meter, 1 inch, 1 unit. With a unit circle, you can construct a right triangle with a radius, a sine, and an altitude. In this case, our ratio is about 0.8 to 1. You can see the hypotenuse is longer. And the sine to radius ratio in a unit circle will always have a 1 on the bottom because the radius is always 1. Let's look at another example. Here's a radius, unit 1. We have a sine. It's about 0.6. Here's another one. The sine is getting shorter now. This time the sine is only about 0.4. And again, we have 1 on the bottom. What makes this so clever? Well, you can take a right triangle of any size and shrink it into a unit circle. So you start with a big right triangle, shrink it into the unit circle. The radius, which is the same as the hypotenuse, is always 1. When we see a number over a number, we know we can divide the top number by the number on the bottom. So 20 over 5 is the same as 20 divided by 5. But what happens when the number on the bottom is 1? Well, 20 over 1 is the same as 20 divided by 1. Well, a number divided by 1 doesn't change, so we can cancel the 1. 20 over 1, cancel the 1, it's just the same as 20. Now here's an example. The ratio of the sine to radius here is 0.5 to 1. But when a sine to radius ratio is 0.5 to 1, we can cancel the 1 on the bottom. So I cancel the 1, so the sine to radius ratio is now just 0.5. You can imagine there's a 1 on the bottom, but it's canceled. We know that it's there in reality. But math people like to simplify things the way they look. And since the radius of a unit circle is 1, we can also cancel the word radius, because it's 1. So now we've simplified it to just look like sine equals 0.5. That's why the sine to radius ratio is abbreviated as just the sine. Instead of saying the sine to radius ratio of a right triangle with a central angle of 30 degrees is 0.5 to 1, which is a lot of words, we just say the sine of 30 degrees is 0.5. Much quicker, same meaning. The abbreviation SIN, sine of 30 degrees, equals 0.5. As you saw in the part 3 video, there's another way of naming the sides of a right triangle. We have the two legs that form the right angle, and the hypotenuse, which is opposite the right angle. If we look at the two legs from the perspective of angle A, one leg is on the opposite side of the triangle from angle A, so we call it the opposite leg. The other leg is adjacent to angle A, right next to it, so we call it the adjacent leg. Looking at the triangle still from the perspective of angle A, we can also refer to the opposite leg as the opposite side. Same idea. And the leg that is adjacent to angle A can be called the adjacent side. The hypotenuse already has a name. Angle A's opposite leg or opposite side is usually abbreviated as just opposite. Angle A's adjacent leg or adjacent side is usually abbreviated as the adjacent. So naming the sides of a right triangle, here's angle A and there's the opposite side, the adjacent side, and the hypotenuse, with a 90-degree angle, of course. Now, here's the other way, which we looked at before, where it comes from being constructed in a circle. Here's our right triangle with angle A in the central angle position. We have a radius, an altitude, and over there on the opposite side is the sine, the half chord. So here we can compare the two ways of naming the sides. Opposite, adjacent, hypotenuse, sine, altitude, radius. Same thing. Now, let's name the ratios. We'll just use two of the sides. On the left, we see we can compare the opposite side to the hypotenuse and make a ratio or a comparison that way. But over in number 2 on the right, the same thing we would call comparing the sine to the radius. So sine over radius equals opposite over hypotenuse. They're the same thing with different names. But when you think with a unit circle, the radius, of course, is 1. So when you have sine over radius, we will cancel the word radius to make it look simpler. So now it just looks like sine equals opposite over hypotenuse. And that's a very important definition. The sine, or the sine ratio, is the opposite over the hypotenuse. Here's an example. The sine is 0.5 over 1. In other words, just 0.5 if you want to take out the 1 to make it more simple looking. Here's another example. There's that classic 3, 4, 5 right triangle. The sine, compare the opposite side to the hypotenuse, will be 3 to 5. Well, a number over a number means you can divide. 3 divided by 5 is 0.6, that's 6/10. Here's another one. Now our sine is going to be 5 compared to 13. 5 over 13, or 5 to 13. When we divide that, we get 0.3846. And actually the numbers continue, but that's rounded to those 4 digits. So now our sine of that figure is 0.3846. Looking at this triangle, the sine to radius ratio of the triangle with a 30-degree angle is 0.5 to 1. And the quick way of saying it is sine of 30 degrees is 0.5. Now let's look at some other examples. We'll lead off with 30 degrees. We have a 0.5 to 1 sine ratio. Now, as the central angle gets bigger, we've rotated the radius now to 35 degrees, well, the sine is going to get longer. You can see this sine is, instead of 0.5, it's 0.5736, getting a little bit longer. As we rotate to 40 degrees, the radius is still 1, of course. Well, the sine is getting longer. Now it's grown to be 0.6427, or 8. And 45 degrees, the length of the sine is 0.7071. Well, that is your introduction to sines. Sine can be part of a circle, part of an isosceles triangle, part of a right triangle, part of an equilateral triangle, or a ratio comparing the lengths of two sides of a right triangle. How you actually use this information about sines will be addressed later. You can use a calculator to find the sine of any angle up to 90 degrees, or you can use this trigonometry table. You can see on the left column is the angle in degrees. Next to it, the next column is the sine. You see where the hand is pointing 30 degrees, the sine is 0.5. And right below that, you can find the sine for 31 degrees, 32, 33, and so on, all the way to 45. Then you can go up to the next one to find for angles larger than 45. Thanks a lot for watching my video. Please share these ideas with people who can benefit from them.